Welcome. Good morning, good afternoon, good evening, depending on the time zone you are at. Welcome to the Past Marathon, and welcome to our predictive analytics with R in Power BI. My name is Armando Lacerda, and I am your panelist here. I will be helping you out with controlling the session, and Joseph is our speaker of this session. So before we get into the actual session, let me go through some introduction words in here. Then once again, hello, welcome to our Past Marathon Analytics. We are excited you could join us today for Joseph Yeates' session about predictive analytics, like I mentioned. This Past Marathon features back-to-back live webinars delivered by experts, speakers from the Past community. That's what I love about Past. It's all about the community, right? Us helping ourselves. That's great. The sessions will be recorded, so yeah, I have already answered your question. You're going to ask me, I know if this is going to be recorded or not. There we go. They are going to be actually they are being recorded right now. Like I said, my name is Armando, and I will introduce Joseph in a second. In case you have any technical issues, you can try to ask your questions through the chat window. We'll be standing by here to help you out with any technical difficulties you may have, and we are able to to support you. We do have a place for you to ask questions about the session itself. So if you have any questions for the speaker, please use the question slot you have there on GoToWebinar. And we're gonna, if I can help you out, I'll give you a piece of my knowledge, but we'll read all of them at the end of the session to Joseph. Next slide. Let's see. Yeah, so our sponsor for this event, for this Past Marathon, is Quest. So thank you, Quest, for sponsor this event. This marathon wouldn't be possible without your support. If you would like to learn more about them, please check their websites, visit the Past Marathon website as well. They offer great products to help us out as DBAs. Just a couple weeks ago, we had the Past Summit. Is the first icon there on your slide, on the previous slide, Joseph, please. We had the Past Summit. It was an awesome event. It's an event I look forward all year long. You know, it's about the whole community collectively sharing our expertise and learning from each other, getting a chance to talk to not just to the experts in our area, but also from a Microsoft team with the data clinic they're having there. So yeah, it was just 2 weeks ago. Let's make our plans to attend next year, right, in November next year. PES is also about local groups. We have both virtual groups and local groups. I live down here in North California, and we have one in San Francisco, another one in Sacramento. There are great groups, and it's always a good chance to expand your network with technical people, and also the virtual groups. So check the PASS website and choose one of the groups, either the specific subjects like BI. There is a great BI group, virtual group in there, or more generic ones for DBAs and developers. Get involved with PASS volunteers. All we do here is all volunteer. Joseph is a volunteer his time, and volunteer my time. Is all about we helping each other, like I have said so many times. So get involved. Great, you're here. You already have an account with PASS, so look for an opportunity to help out the community to grow and everybody to learn new things, new tricks. So with that said, it's my pleasure to introduce Joseph. In the next slide, there we go. Joseph, this Past Marathon session is presented by Joseph Yeates. Joseph is a data enthusiast and blogs about all things Power BI or on Feathers Analytics. He has a passion for creating compelling data narratives and making insights accessible to a wider range of users through visualization. He holds the Certified Analytics Professional designation as well as a DBA certification with a focus on SQL Server analysis service and reporting service. So Joseph, take it away.
All right. Well, thank you, Armando, for the introduction.
Sorry for interrupt you.
Yeah,
I believe
no
you want
problem.
me to run the first poll, right? Is that true?
Yes, yes, absolutely.
Yeah, there we go. I forgot about that. So Joseph put together here two pools for us guys, for us to respond. So the pool is gonna show up on your screen, and please pick an option there when the pool shows up. So let me put it up in here. The first one is, which topic are you most interested in? And you have three options there: Power Query, Power BI, or R for this session. So go ahead and start clicking away there on your screens. All right. I'm going to give you just a few more seconds. Still a lot of activities going on here. A lot of people. If you don't know what Power Query or Power BI or R is, you're in the right session too. So Joseph, the
Yes.
majority, 77%, actually 71 now, 71% is about R. They are really looking forward for R.
Awesome.
And head to head, we have Power Query and Power BI. I believe Power BI, by Power BI, you mean DAX. Is that true?
No, no, just Power BI is the desktop application.
Oh, the desktop application. Okay.
Yeah,
So there we go. We have a winner. The winner is R with 67%.
awesome.
Now let me close this and get back to your slide deck.
Okay. All right. Well, thanks, Armando, and thanks everyone for attending today. So, based on the poll, a lot of the interest in this session is going to be based on R. So, we are going to look at Power Query and Power BI as well. But since that's the feedback that I got, we're going to be pretty intensive on the R part as well. So, just before I get into the agenda today, I just want to go over the key aspect and really the key takeaway, I think, for the session is just to be inspired. It's only 50 minutes that we have to go through the material. So ultimately, I just want to introduce a few new concepts and hopefully this piques your interest and then you can go away and do some more learning about these topics later on. Unfortunately, we don't have a lot of time, so we can't cover all of the best practices when we go through some data science and writing some R code. And so, because that's the case, some of these best practices have been done in the background, but we don't necessarily have time to address them in the presentation. So how I'm going to start off today is we're actually going to start in our Power BI report. And we're going to do this because we're going to do some initial exploratory descriptive analysis visually in Power BI. So after we build some basic summary statistics and report visuals, I'm going to flip back into my slide deck and we're going to go over some key concepts of predictive analytics and building predictive models in R. From there, we're going to drop anchor. We're going to head into our R Studio and we're going to go through and do some more exploratory data analysis. And at this point, we're actually going to build 3 different predictive models. Going to come back to the slides and then we're going to go into Power BI and I'm going to cover 3 ways that we can integrate the power of these predictive models into our Power BI report and start that shift from a descriptive to a predictive analysis with our data. And then after I've gone over that integration, we're going to wrap it up with some Q&A. So starting off with descriptive analysis, and our business scenario today, the data set that we're going to be working with is we're going to be looking at Premier League fantasy football, or for anyone in North America, this is soccer. And so the goal of the game is that players in the fantasy game get points based on real life performance of players in the English Soccer League. And fantasy players such as myself, we want to pick our teams and ultimately we want to score the highest amount of points so we can get bragging rights with our colleagues at work. So just like any other business scenario, we have our goal is to get the total amount of points, but we are subject to some constraints as well. We have a limited budget that we can spend when we're putting our team together of £100. And then we're also subject to some constraints with the positions of players. We need a certain amount of players across 4 different positions in our team. We can't just pick a lot of a certain type of player. Some other important factors to consider as well is that the player's price changes based on activity in the transfer market. So when players of the actual fantasy game, such as myself, see a player performing well, we may want to transfer them into our team. And as a player gets transferred into more teams, their price is going to go up. Conversely, if a player is not performing very well, fantasy players may transfer those players out of their team and their price is going to drop. So that's a really interesting and important factor to consider, is that the market actually sets the price for these players. Our final important factor, and something to keep in mind as well, is also that round about 50 points a week is going to put us in a good place, at least in leagues that I participate in. So a good rule of thumb to consider as we're putting our team together is we want to be scoring about 50 points a week. So with that, I'm actually going to flip out of my slides and we're going to go into Power BI and we're going to start building our exploratory analysis with some visuals. So I've already put together some basic summary statistics. We can see down the left-hand side of our dashboard here, we have total points. So all of the players in the fantasy game so far this season has scored about 8,200 points. The average points per player so far this season is just over 16 points. The average price is just over £5, and the average price change per player has actually decreased. So that's interesting that on average, players' prices decreased over the course of the season. I've also pre-built just a basic summary table with some information about some of the fantasy league players. I've sorted it by our total points column, so we can see as of now, the top 3 highest scoring players in the game are Eden Hazard, who's a midfielder, Marcus Alonso, who's a defender, and Mohamed Salah, who's a midfielder. So these 3 are our highest scoring players so far. To build our first visual, I'm actually just going to copy and paste this table visual and move it over here. And I'm going to convert this to a scatter chart. I'm going to take out some of the additional fields that we don't need, like fields in our play axis and our tooltips. And so this leaves us with something that looks like this. The only thing I'm going to change is I do want to detail our scatter plot with our ID. So now we can see that we are plotting on our x-axis the price of a player. So this was one of the big constraints that we're faced in our game. We have price on our x-axis and we have total points on our y-axis. So total points, again, is the objective, and we want to try and find players who are going to score a higher total points. I'm going to format this scatter plot where I'm going to go into the little paint roller brush under our report visualizations pane. And here I have some formatting options for our visual. So under the legend, I'm actually going to put that in the top at the center, and I'm going to make that a white color so it's a little bit easier to read. And I'm also going to do the same thing with our x-axis. It's going to make it a little bit easier for us to see and boost that font size up. And I'm going to do the exact same thing for the y-axis. I'm going to set that to white, and I'm going to increase the font size. The last thing any visualization needs, or any visual on a report, is a descriptive title so that our users can see exactly what's going on. And we're going to name this visual something creative like total points by price. And the same as some of the other formatting, I'm just going to move that into the center and boost the font size up a little bit. Awesome. So if I want to zoom in on this, I'm just going to go into the focus mode for this visual. And what's interesting that we can see, there seems to be a positive relationship between price and with total points. So as a player price increases, the total amount of points that they score also increases. So that's interesting because that seems to indicate that we have an efficient market and that it's pricing players correctly, that the players who are higher scoring cost more. So that's good. I'm going to create a second visual as well, and I'm going to do the same thing. I'm going to just copy and paste the scatter plot, but I'm going to drag it down into this bottom left-hand corner here. And I'm going to change this a little bit. So we looked at total points by price in the top right. I'm actually going to change this so that we have the individual team that a player plays for on the x-axis. I'm going to increase the size of those bubbles so we can see a little bit more by going to the shape formatting. And then I'm going to sort by total points. Perfect. And all I need to do is change the name of our title from total points by price to total points by team. So now this is interesting. We can see along the x-axis, the teams with the highest scoring points are Manchester City, Chelsea, and Liverpool. And at this point, these are the three top teams in the Premier League right now as well. So it kind of makes sense that they're three teams that are doing really well in real life, and their players are all scoring really high as well in the fantasy game. One thing I think is particularly interesting is if we look across these top section of the top scoring teams, we can see that those pink bubbles are up at the top, followed by the blue bubbles for the position of the highest scoring players. And then we have a big gap in the middle here. And after the big gap, we drop down and we see those yellow and dark blue bubbles or points in our scatter plot. And that's really interesting because we can see that the highest scoring position are actually defenders and midfielders. I would have assumed that forwards would have been the highest scoring position. So maybe there's something about this that we need to look into further with our analysis. So to create our fourth and final visual in our Power BI report, I'm just going to I'm going to copy and paste our report visual, and I'm going to drag it over into the bottom right-hand corner. So rather than a third scatter plot, I'm going to change this to a column chart. And I'm actually going to take team short off of the axis, and I'm going to drop position on again. So right now we have position on our x-axis, and it's also the legend for the graph. But rather than total points this time, I'm interested. So based on the insight that we got from this scatter plot over here, what is the actual average points by position that are scored? And since we only have 4 categories, we only have 4 positions that we want to deal with, I'm actually going to turn data labels on for these columns. And I'm going to make this a little bit bigger to make it a little bit easier to see, boost that font size up. And because we have these call out values, we don't need these relative lines up and down on our y-axis. So I'm just going to go into formatting and turn the y-axis off. Okay, so this is interesting. We can see that goalkeepers and defenders have a lower average point total than midfielders and forwards. So that makes sense because midfielders and forwards generally in the real game score more points. But this sort of contradicts what we saw over here in that for our top scoring teams, its defenders are scoring really highly, but down here they have a lower average points. So that's something that we may need to analyze a little bit more. But this is going through, and in just 5 to 10 short minutes in Power BI, I was able to build 4 visuals that really give us a better idea of our data and allow us that we have a starting point now that we've asked questions with our data visually, and we can go in and it can guide us and it can direct us, and we can think, okay, maybe these are some of the questions of our data we can be asking that can drive better insights and drive better business intelligence. And one thing I'm going to do just before we flip back into the slides is I'm going to update this title, and I'm going to make it average points by position. Perfect. So that was the business scenario that we built. And in our Power BI report, just to summarize, we did some initial exploratory analysis with data visualization, and we were mostly concerned with total points because that is the goal that we're looking at in our business scenario. And we also looked at price and position across 2 of our scatter plots. And that's because those are 2 of the big constraints that we're faced with in our business scenario. So just before we get into R Studio and start building some predictive analytics in R, I just want to take some time to snap back and review some key concepts of predictive analytics. So 2 key concepts that are going to be particularly important today are performance and generalization. So the performance of any predictive analytics is how well does our predictive model actually predict the dependent variable or the target that we're trying to predict. So it's great that we have the ability that we can go in and build and try and predict something, but ultimately this is useless unless we can measure how well is that model performing, how well does it predict what we're trying to predict. So that's a really important concept. And the second one is generalization. And this is how well will our model perform on new variables and new data and unseen points as they come in. So this is slightly different than performance, because performance is just how well our model predicts the certain data set that we're using right now. Generalization means that as we apply this model on new data points, we might get new transactions coming in, we might get new clients, there might be new games in our fantasy data. We want to be able to know with some degree of certainty that how our model performs as we're building and testing our model, it's going to perform in a similar way on new data points in the future as it comes in. And we need to make sure that it generalizes well, because otherwise it's going to prove useless over time, and it's not going to have a good return on investment, and it's not been a good use of our time. So these two key concepts are extremely important when we're building any predictive analytics. And these are two things that we're not going to have time to get into huge detail actually in the code today, but they're two hugely important concepts that should go into any data science coding and modeling. So the three models that we're going to be building today is we're going to be building a k-means clustering model, a linear regression model, and a classification tree. So we're going to build these three models, and these three models are techniques used by machine learning programs, and these machine learning programs use these exact set techniques that we're going to be going over and building by hand in our studio. So our k-means clustering model, this is an unsupervised technique, and this requires from the analyst building it interpretation and configuration. A k-means clustering ultimately shows us patterns and relationships in our data between different data points, and it's up to us to interpret these patterns and relationship and decide, is there anything valuable here? Is there anything we can take away to drive better business decisions? And this is an iterative process with 3 steps, and I'm going to explain what this means over the next 3 slides. So our first step is that we plot our data. So you can see all the red dots in our scatter plot. We're plotted our data set across some of the different dimensions. And then we randomly plot 3 centroids, or a number of centroids. In this example, it's 3. So we plot 3 centroids across our data. So we can see 1 is red, 2 is green, and 3 is blue. After we've plotted these 3 centroids, we go and we assign the data points in our data to the nearest centroid. So we can see over to the left-hand side of the scatter plot, around centroid 1, all of those red dots belong to that first centroid. In the middle of the plot, around centroid 2, which is green, we have all those green plots and spots because they're closest to that second centroid. And same thing for number 3. We have all the blue points towards the top right-hand side of our scatter plot, and they've been assigned to that third centroid. So after we've assigned data points to the nearest centroid, and every data point has been assigned to one, this comes to our third step, and we actually move that centroid. So in the first step, it was just plotted randomly across our data. We've assigned each individual data point to a centroid, and now we move these centroids to the average place of the data points contained in there. So we move these centroids, in the first case of number 1, up a little bit because that's the average place of all those red dots. We move the second centroid left a little bit because that's the average place of that green group. And the same thing for centroid 3, we move that left a little bit. And after we've done this, we actually go back and we do this process again. And we go through these 3 steps and we reiterate until we're happy with the results, that we're at the optimal placement of those centroids and the optimal assignment of our data points to those centroids. The second model we're going to look at is a linear regression model. So this is a supervised technique, which means that it requires us as the analyst to provide it with labeled input and explicitly define what are we trying to predict, and these are some of the values that we want to predict. And essentially what a linear regression model does is that we fit a linear equation to try and model the relationship between our target variable, between what we're trying to predict, and some predictive variables that we're using to try and predict this target. And in our data set, it's going to look something like this. We have that same data set plotted, and if we fit a line, this is exactly what a fitted linear model is going to look like. We have an equation that's going to have the plot of that line, what is the intercept on the y-axis, and what's the slope. And we can interpret the slope of this line as the relationship between our x-axis and the y-axis. So our final predictive analytic method we're going to be looking at today is a classification tree. So a classification tree, again, is another supervised method. We have to explicitly input labeled observations into it, and this requires configuration. And our goal, and when we go through our classification tree, is that we want to split data into groups with a series of yes or no questions. So what this looks like, the output is something like this, where we have all of our data at the top, and then we have a question based on a column or a variable in our data. And if we answer this question yes, we're going to go to one side of the tree. And if we answer this question no, we're going to move to the other side of the tree. So with our predictive analysis, those are some key concepts that we just reviewed, and I went over the 3 models that we're going to build in R. And there's just a few key concepts of R that I want to go over before we jump into our R Studio. So the feedback from the poll, I heard that most of you, I think over 2/3, interest in this session was based on R. So R is a programming language used for statistical analysis, and more importantly, statistical computing and data visualization. So I'm going to jump into R Studio and go over some code. But first, there are 3 key points that I want to go over about coding in R. The first is this concept of assignment. So we can see on the slide, we have our file path and then a little arrow. And next to it, in quotes, we have a text string. So this can be interpreted as we want to assign file path. That's what the arrow means. We're creating the object of file path. And in that file path object, we're assigning it the value of that text string, that file path of user's source data, the Excel file. The second concept of R is functions. So if we look down on that second bullet point, we can see we're actually doing that read Excel function. So we're doing the read Excel function, and we're running that. The data input to it is file path. And another argument, which is separated by a comma, is that sheet is equal to data. So what's interesting about this is that we're actually running that read Excel function onto the file path object that we defined in the previous step. And we're storing the output of this function into our source data object. So our third and final concept of some basics in R is piping. So piping is that percentage, right arrow percentage sign we can see in the third bullet point. And what that means is that we're actually piping the output of the previous step, and that becomes the data argument of any subsequent functions on the next line. So that third statement can be read as we're going to pipe source data into our select statement. That's the data that we want to select our ID and our total points column from. And now that we've selected just that ID and our total points column from source data, we're going to store that into our new data object that we just created. So with that, I'm actually going to flip back into R Studio, and we're going to get our hands dirty looking at some code. So the very first thing we need to do before we start coding in R or building anything is we need to load any packages that we may require for our analysis. So R does come with some standard functionality, and this core functionality is called core R. This core R can be extendable via packages. So as we load some packages, that gives us some more functionality and more functions to work with to drive our analysis. So for example, today I just need 5 packages, and I can call on these by using the library function and calling those 5 packages. So I'm going to run that code to load our packages. And we can see in our console over here, we have some interesting things happen. It loaded our 5 packages. The next thing I want to do is import some data. So all the data that we need is in an Excel file. And this is actually the same as the data source we used to build our Power BI report earlier in the presentation. So I'm just going to go over this entire chunk of code and I'm going to run it. And we can see this leaves us with an object called dataset. So if I go down here into our environment, we can see that we have this dataset object. We have 504 observations of 9 variables, or 504 rows and 9 columns. And we can see what these are. We have our ID, total points, now cost column. So those are the names of our columns in our dataset. We can quickly look at the data type. We have character, numeric, and numeric. And we have a preview of the first few rows of data in those columns as well. So now I've imported the data into R. And the first thing we want to do, just like how we did in Power BI, is maybe we need to inspect our data and do some exploratory analysis via visualization. So this is made really easy through a plot function. And I'm just going to zoom in on this. And by using just a few lines of code, this has actually created a scatter plot for us that plots all of the variables in our data set against one another in a matrix view. So how I'd interpret this is if I start over here in the top right-hand corner, we see a lot of straight lines up and down, but those straight lines are pretty cloudy. They fill up the entire box. So there doesn't look to really be any strong relationships between the variables that make up these few plots in the top right. If we go into the bottom right-hand corner, we see the same thing. We have a lot of single points on our scatter plot. It's pretty cloudy. They fill up the whole box. So there's not really a relationship between the X and the Y axis or between these data points. If we move over to the bottom left-hand corner, similar sort of idea. We see some bunches down here in the bottom left-hand corner of all of these plots, but nothing really jumps out to us. It's when we get into this top left-hand corner. For me, 2 of these really jump out. I see this one, which is total points in minutes, seems to have a strong positive relationship. And if we look at total points by minutes flipped on the other axis, same thing. This really looks like as minutes increase, total points increases as well. So that's something to keep in mind as a relationship between these 2 variables as we move through our analysis. So now that we've looked at and just visually we've seen, okay, it looks like there's a strong relationship between some of those variables. We can prove that out statistically by building a correlation plot. So this visually displays the correlation between some of our different columns in our data. So the bigger the circle, the stronger the correlation. If we see a dark blue, the darker the blue, the stronger the positive correlation. If it's darker red, it's a stronger negative correlation. So a negative correlation means that as one variable increases, the other variable decreases. A positive correlation means as one increases, the other increases as well. So I'm going to exit out of that, and I'm going to scroll down. And let's actually build a visual. Let's build a histogram based on our data set. So this is plotting points per 90. This is a variable that I created. We saw that there's a really strong relationship between total points and minutes. So I actually took total points, divided it by minutes, and multiplied it by 90 to create a new variable called points per 90. I multiplied it by 90 because there's 90 minutes in a soccer game. And this resulted in the following histogram. So we can see that it looks pretty normally distributed up into the left-hand side of our graph. It spikes up. It has a long right tail. But then it looks like we have some outliers way down here to the right-hand side as well. So that's interesting. Maybe that's something we need to look at. So I'm just going to take a look at the top scorers based on our points per 90 variable that we created. So we have our top scoring points per 90. We have 90, 90, 45. And these seem to correspond to those peaks and those big outliers on the other side of our histogram. And what's interesting is when we look down, we see, oh, okay, the minutes they've played are really, really low. We just have 1, 2, 4, 14. All of these were in the single or double digit numbers. So that's something that we need to filter out. And when we filter those out, we can see that our density plot is a lot more normally distributed. So that's good. We're more comfortable that after we've filtered out those players, with a low minutes played, we're comfortable that we can go ahead and carry on with our analysis after we've filtered out those players. So from here, we've actually created our final data set. We're happy with how it looks now, and I'm going to create our data set we're going to be working with to build our models, and we're going to call this model data. So to build our k-means clustering model, this is fairly straightforward. I'm just going to run this code. And we can look at the results if we want to. We have cluster, we have centers. The only thing we really care about is the cluster that we've created. And I'm going to add that as a column onto our model data. So now we can see we have our points per 90 column as well as the cluster that we've created as well. I'm going to skip over visualizing those results. And we're going to move on to our second model of linear regression. So to build a linear regression model, we just need to use one function, our LM function. And I'm going to run this. And the same thing that we did for our previous example from our cluster analysis, I'm going to store that as a column onto our model data. So when I look at that now, we see we have a cluster column as well as a linear model column with a score. That was the output for the model that we created. Finally, I'm going to build our classification tree. But to build our classification tree, the first thing I need to do is bin our points per 90 variable. We want to bin this into some categorical or ordinal ranges. And we're going to do this based on the distribution of this histogram. So between 0 and 2.5, which is about here, we're going to label all of these players scoring in points per 90 in this region as low. Anything between 2.5 and 5.5 in this meaty part of the distribution, we're going to label as medium. And then everything to the right, we're going to label as high. So I'm going to run that, and that's going to add a points per 90 bin variable. And then we're going to build our classification tree model based off of that variable. And then we can look at the results of that as well. So if I blow this up, we can see goals scored, clean sheets, and position all seem to be pretty significant in breaking down and splitting our data into these groups at the bottom. All I need to do now is add that as a column to our data set. So when I inspect it for one last time, we can see we have the score of our linear model, the score or the cluster that we built with our cluster model, and the score from our classification tree. And at this point, I'm going to go back into our PowerPoint slides. So we've built these three great predictive analytics in R, these three predictive models. We've built a Power BI report from beginning for some descriptive analysis. But how do we start to integrate some of the power of those predictive models into our descriptive Power BI report? And really, this is where we're showing where do we want to go. We've started with the descriptive analysis, and today I'm going to demonstrate how we can begin that shift from a descriptive to a predictive analysis. And I'm going to demo three ways that we can integrate these three models. We can use our R script as a data connector. We can actually run an R script in our Power Query applied steps. And we can also build a custom R visual as well. So with that, I'm going to flip back into the Power BI report. And this is where we started. And these are the visuals that we built at the beginning of the session today. So our first way is I can connect directly to an R script. I'm going to go to the Get Data tab on the ribbon, and I'm going to go down to the More options at the bottom of the drop-down list. And this is going to bring up all the possible data sources we can connect to in our Power BI report. I'm going to navigate to the Other option at the bottom of the menu on the left-hand side. And then about halfway down, we see the option for R script. We want to connect to an R script to get our data from. And when I hit Connect and commit to that, this brings up this really inspiring white and blank R script pane. And all we have to do at this point is go back into our RStudio, and I'm just going to copy across some code that I can paste into our R script dialog box, and I'm going to hit OK. So this loads the navigator pane, and we can actually see the two objects that we created when we went through our R code in RStudio. We can see this initial data set, which is the data that we imported and cleaned up a little bit from our Excel file. And then we can see model data. And when we scroll over, we can see we have our points per 90 and our cluster column that we built using our cluster algorithm. So I'm going to select model data to load, and I'm going to hit edit, and that's going to bring us into the Power Query editor. So from this data set, all I really need is our ID and our cluster column. So if I control click on those two columns, I can just right click and remove all the other columns. Let me go back. So we click on ID and cluster. I'm just going to right click and hit remove other columns. And this is all we need to do to land that data into our Power BI report. Another way we can achieve the same thing, so I'm just going to go to the Choose Columns button on the ribbon, and all I want is ID and cluster, and it achieves exactly the same thing. But using an R script as a data source, if I actually go back and delete those two steps, we can see that we created two objects in our R code that we copied over. But knowing that all I really want is to select the ID in the cluster column, I can create a third object in that code. So let's call it Power BI data. And all I want to do is select from our model data object the ID and the cluster column. And when I hit OK, we can see this actually renders a third object that we can connect to of Power BI data. And when I navigate into that, it just returns our ID and our cluster. So we can do that exact same manipulation in both Power Query and Power BI or R. So the only one drawback of this is that we've built some great code in our RStudio, in our development environment, and we've copied it over to drive our Power BI report. So the only drawback to this is that if we go back into RStudio and maybe next week or next month or next year, we're going through our code and we think, oh, okay, actually, let me make some changes and let me make some enhancements to our models. Maybe we need to recalibrate it. We have to remember to go back and from our RStudio, copy paste our code back into our Power BI, back into this R script pane. And I don't know about you guys, but I would forget to do that all of the time. So one thing we can do instead of just copy pasting that code, we can actually use a function called the source function. And that hits the R file that we created in our RStudio directly. And that pulls in the two objects that we created. And then when I drill down into here, any changes that I make in our development environment and I save into that R file are now going to be pulled through into my Power BI report. So at this point, I'm happy. I'm just going to close and load that. And now on the right-hand side, under our fields pane, we have game stats, which is the data set used to build our report in Power BI. And we have this new model data. So to bring the power of our cluster model into our Power BI report, it's just as easy as dropping our legend, our position from our legend field, and dragging cluster in. And now we can see, just like that, the model that we built in R is now being used in Power BI to color a scatter plot. So I think that's pretty cool. The second way that we can integrate the power of an R model into Power BI is as an applied step in our query editor. So if I hit edit queries, this is going to take us back into our query editor. And I'm actually going to go to our game stats, and I'm going to reference this to create a new query. And I'm going to call this one R prediction. So at this point, game stats, this looks a lot like our data set, which is where we started in RStudio before we filtered and manipulated it down. So I can copy and paste those manipulation steps from our R code and just paste them into Power BI. Or I could just go through and recreate those in the Power Query editor itself. And that's exactly what I'm going to do. So all I need is to return a few variables that we actually used for our analysis. And that mirrors the select statement that we used. I need to filter our minutes to be greater than 180, just like we did in R. And I also need to create our points per 90 variable. So I want to take total points and divide that by minutes. I'm going to add a column by dividing these two columns together. And then I want to transform that column I just created by multiplying it by 90. And at this point, we've created our points per 90 column, just like how we did in R. And I can go back and delete our total points and minutes columns because we don't really need them. And I'm actually going to go back and just change one quick thing. And when we rename our columns, I'm going to call this one position. And then remove columns. So now we're left in the exact same point where we were, where we left off in RStudio. This is exactly the same as our model data set. So if I want to insert and integrate the power of our linear model into Power BI, I do go to the Transform tab, and over on the right-hand side, we have an option to run R scripts. If I go back into RStudio, I just need to copy 3 lines of code, and just like that, I can paste it in. And this runs the R script. Oh, we have an oh, that's what I did. I'm going to go back. We're just going to add in clean sheets. I forgot to do that. And now when we go back into our R script, we can see over to the right, we have this score LM column, just like how we built in RStudio. So if I close that, our first step, I just need to make sure that our R prediction query is related to our game stats. And maybe one insight I'm really interested in is what players really outperformed their prediction. So, we predicted a player to score a certain amount. Which ones are doing way better than the model thought that it would? And we actually have that if we subtract our points per 90s column by the score of the predictive model. I can pull that insight into our Power BI report. So maybe I want to drag lift onto our axis, and instead of position, I actually want to see which individual players are doing really well. And I'm just going to drill down, and I'm going to do a top and filter on our ID that I just want to see the top 10 players based on that lift column that we just created. And when I hit apply and sort by lift, we can see these are the top 10 players that are outperforming our prediction and doing way better than the model thinks they should be doing. So maybe these are some great value players that we should add to our fantasy team. Maybe these are some players that we should look to bring into our team because they offer great value. They're outperforming our predictive model. So the third way that I'm going to demo today, and this is the last part of the presentation, is we can build a custom R visual in Power BI. So I'm just going to go to the big R script visual, and I do want to enable that from our visualizations pane. And if I make that a little bit bigger, I'm just going to go and I'm going to start dropping in some fields into this visual. So we need ID, we need our points per 90. We don't want that summarized. We need our position, selected by percent, and all the different columns that we were using in RStudio. We're going to build our R script visual in Power BI off of the same thing. And all I need to do to power this visual is go back into RStudio, copy some code over, and then when this runs, we can see we've created our decision tree native right in Power BI. And so this is a really big tree. There's lots of splitting points of our data. If I want to make this simple, just like our one in our RStudio was, I can add in and go in and change just one more argument in our function, rerun that, and we can see once it runs that our tree has changed a little bit. It's a little bit more simple, and then we can interpret this tree and bring back some value to our business analysts and value that is a lot more accessible than if it was to just reside in RStudio. So just to recap, these are the three ways that we integrated our R model into Power BI. We used an R script as a data source. We ran an R script in our Power Query editor, and then we just created a custom R script visual in our report as well. So that wraps up my presentation for today. Thank you guys, and I'm just going to hand it back over to Armando to see if there's any questions that came up throughout the session.
Fantastic. That was a great presentation, Joseph. I learned a lot. And the question panel here is still empty. So let's give a couple minutes to our attendees to see if they come up with some questions for you.
Awesome.
I do have a question for you, though. On the RStudio, you load an Excel file through the R script. Can we do the same with the Power BI R visual?
So that's a great question, and I'm actually just going to go back into our Power BI report to answer it. So how this visual is powered is, you can see over here, we've dropped from one of our queries on the right-hand side, we've dropped some data fields into this value section. So this is the data set that this visual is powered off of. What's default into this R visual is that these two steps at the top, it creates a data set and a data frame out of all of these columns that we drop into the visual. And then this data set is what we can build to manipulate and build that visual off of. So we can't actually import new data into our Power BI report this way. We can do that through the Power Query editor, but then we drop those fields into the visual, and then we can build our visuals off of those fields that way.
Perfect. Thank you so much. Awesome. So I do have two questions here for you. The first one is actually now three. So the first one is, can we have a download of the demo? Have you shared this in GitHub or someplace?
Yeah, so I actually have all of these example files on a OneDrive folder that I can share with everyone. I'm not sure the best way to do that, but I can definitely distribute that after the session today.
Perfect. If you have a link, perhaps. Go, Eric.
Hi. So Joseph, if you wanted to send those over to me, I can upload those, and they will be next to your PowerPoint slides in the website, in the Past Marathon Analytics website, along with your session recording as well.
Okay, awesome. Yeah, so that's where they'll be then.
Perfect. There we go. I knew the PowerPoint slides were going to be published there. I'm not sure about the Power BI file and the R scripts, but thanks, Eric. Now we know where to find them.
Exactly.
Second question for you, Joseph. So does k-means always start with 3 centroids? From Chuck Jacobson.
No, so that's another fantastic question. I'm just going to go back into RStudio. So like I mentioned at the beginning, we had to fly through this RStudio section pretty fast. There are actual statistical techniques to determine what the optimal amount of clusters or centroid using our k-means model would be. So I've done this actually before, and we determined that it was 3 for this demo. So using this k-means function, we do have to explicitly set, so you can see here, I've set it as 3 centroids. We do have to explicitly set that, but there are ways to find out what is the actual optimal amount of centroids that we can use.
Cool, thank you. And the next one here is from Leonardo Bravo, and the question is, let me see here, just a second. It's related with the start. I gotta read this one here. Hold on just a second. Let me go to the next one. Sure. It was not clear to me the use of decision tree in your example.
Okay. Yeah, I can go over that once more. So is there anything more to that question, or just the whole decision tree wasn't clear?
No, just it mentions this is from Leonardo Bravo again, and he mentions just the decision tree, like how it ends the question, like how is this useful in English?
Okay, awesome. Yeah, so that's a great question. So I've just zoomed into the decision tree in my Power BI report. And how this decision tree can be interpreted is that we're looking to find out how can we split our data into these low, medium, and high groups that I created by bucketing one of our target variables. So how we read a decision tree is that we start at the top and we work our way down. So right at the very top, we can see we have 100%. That means that 100% of the members of our data set are located in this branch of the tree at the very top. And we can see the distribution of low, the number of people who are scoring on that low bucket is 22%, 64% is medium, and 14% is high. So that's why it's this gray color to represent our medium legend. So the first question we ask of all of the rows in our data is the goal scored by that row less than 1? If the goal scored is less than 1 and the answer is yes, we move to the left. And if no, so the goal scored is greater than 1, then we move to the right. And we can see just based on this one splitting criteria and this one variable and this level within the variable, we now have 59% of our population to the left and 41% to the right. And the distribution within this branch is we have 2% scoring low, 74% scoring medium, and 24% scoring high. So we went from 22% of low to 2% of low just based on this one splitting criteria. And then we do this all the way down the tree. We ask these questions. If the answer is yes, we move to the left. If no, we move to the right. And then we're left with our leaf nodes at the bottom of our tree. And the idea with a classification tree is we want to end up with leaf nodes that are as pure as possible. So we can see over here to the left, we have 7% of our population in this leaf node, and all of these people score low, which is fantastic. They're all extremely similar. And all the way on the other side of the tree, we have only 4% of our data set, 8% of the members in this leaf node score medium, and 92% score high. So this leaf node is pretty pure as well, and all the others in the middle fall somewhere in that medium range. But that's how we would use and interpret a classification tree in our Power BI report.
Perfect, fantastic. Leonardo, thank you for that. Make it clear and also answer the question I wasn't able to read first.
Okay.
And the last one I have here for you is a kudos from Varshan. He writes, great demo. In case you're familiar with Python, please, could you compare them in a high level?
Yeah, so that's another fantastic question. So yeah, if I go back into the Power Query editor, we can see that one thing that's come in really recently in Power BI, if I just go into the R, is we have R script. That's been in Power BI for a long time, but it's Python script. So I'm a lot more familiar with R than Python. They're both really popular languages for doing any statistical analysis and any data science. I probably can't speak well enough on Python to do a high-level comparison of the two, but I know that both of them have their quirks, but they're both extremely powerful for doing data science projects.
Perfect. Thank you so much. And that is the end of our time, right? We're 1 minute before the hour. So, Joseph, thank you again for the awesome presentation.